You know, in spherical coordinate, it even messier. Solving equation itself does not take much time. Writing takes longer. Again, all the equations here will be given in examination room. They are listed in Appendix B. So whenever you do the homework, as I said, derivation will be done in vector form, but in practice, we will use the scalar form. All right? Done? No. No. All right, let's start from the first one. R component. First term, is it 0? Yes. Oh, by the way, in your examination, when you drop each term, you need to give a reason. If you drop without a reason and you drop it incorrectly, you get 0. Okay? So here is 0. Why? Steady state. This term, is it 0? Yes. VR here is 0. All VRs are 0. Is this term 0? Yes. V zeta is 0. So we have 0 on the left hand side. Is pressure a function of R? No. Or if you want to keep it, you can keep it. And you shall see later. VR is 0. So these terms are essentially 0. V zeta is 0 as well. Is GR 0? GR is 0. So all the equation that you write, just 0. So what you have here would be pressure is not function of R. Okay? Equation just tell you that pressure does not change with respect to R. Theta component, first term 0 by steady state, V theta are all 0. So all these terms become 0. Is pressure change with respect to theta? No, for sure. This term is 0. So V theta here is 0. There's 0, 0, and VR 0. Is there any G theta? 0 as well. So what you get? 0 equal to 0. Thank you. Last one. First term is 0 according to steady state assumption. VR is 0. V theta is 0. Does Vz change with respect to Z? No. This term becomes 0. So you have 0. Does pressure change with respect to Z? Yes. So you keep pressure term, definitely. Is this term 0? No. So you need to keep it. How about this term? Is 0. Does not change with respect to theta. Does not change with respect to Z as well. Is GZ 0? No. In this special case here, gravity force going against Z direction. So GZ is equal to minus rho G. Okay? GC here becomes minus G. So after long equations like that, normally if you do it right, the result's supposed to be short. The first equation that does not give you anything, does not give you anything for the second one as well. So the third one, can I change differentiation here to total differentiation? Can I? What about here? Can I write all the differentiation here as total differentiation? Does it matter? It does matter. It does matter a lot. If you keep it in terms of partial differentiation, solving partial differential equation requires, I think, applied math 3. How many applied math did you learn? 2, right? So solving partial differential equation requires applied math 3. If you can change to total differentiation, it will be easier. Now, in order to determine whether you can or cannot change it, you need to consider whether pressure is function of Z only. Yes or no? Pressure here is not function of R. It's not function of theta. So it's function of Z only. So therefore, you can change this term to partial differentiation. On the other hand, Vc here, Vc is not function of R. I'm sorry, Vc is not function of theta. It's not function of Z. It's function of R only. So therefore, you can change them into total differentiation. Okay? So I'm going to move this rho G term together with pressure term on the left-hand side. Now, you should notice that this equation is not the same as what you had in example from chapter 2. The equations are different. But of course, the solution is supposed to be the same. The question is, how can you solve this equation? Can you solve it? No? You will be in big trouble. How can you solve this equation?